Recording. This is day 5. This is the last day. Holy moly. We're doing hypothesis testing. Put this at the top of your paper. This is hypothesis testing for one sample. For one sample. The second page is hypothesis testing for 2 samples or 2 data sets, right? So we're comparing the 2 data sets to each other. On the first sheet, we're comparing the 1 data set to a certain number, right? And the second one, we're comparing the 2 data sets to each other. All right, here we go. So we've got proportion. We've got this information. Mean, we've got this information. We're using the t-table, even though sometimes you use the z-table, but we're using the t-table because we have like 15 people, right? Okay. And then chi-squared table, this is the formula that you use for that. Do we need to outline our variables? Like what is n? Total number, right? Okay. P hat is the sample. P is the
supposed to be number.
Population. Q is the 1 minus P. The fish value is your significance level. Okay. X bar is the sample mean. Mu is the population mean. N is the total. What's S? Standard deviation. And you have your significance level. Okay. N is the total. S is the standard deviation for, I'm going to say, sample. Sigma is the population standard deviation. And then this is the significance level. Okay. That's all the information that you need to put into your formulas and such. All right. The proportion of the N equals how many students? How many do we want to do?
Wait, do you want to be involved or no? It doesn't matter anymore, right?
Yeah, for this one it doesn't matter.
Well, actually, you said that last time and it didn't matter. So.
Like it will matter for mean, right? So we'll have to go down to 14 students no matter what here. So should we just do 14? We'll just kick me out. So 14. No. Only 14 students in this class are born in the last 6 months of the year. How many students?
Go back to that thing.
How many students are born in the last 6 months of the year?
No, don't stop.
Right here. Except these are the last 6 months. Except I am one of these. So this is only 3.
2, 6. It's 6.
6 of them are born in the last 6 months of the year. Wait, where are we at? Okay, so
You're acting like you're 6 or 7 years old right now.
P hat will be 6 over 14, which is what percent?
I don't know. My
Point.
calculator's dead for the day.
Dude, my brain is fried out.
0.4 or something?
0.43. 0.43.
Let's go 0.43. We'll make it easier on ourselves. Okay. P hat is 0.43, 6 out of 14. There we go. Use a 0.05 significance level. I'm going to put that down here. Fish, 0.05. Okay. To test the claim that the majority, which is more than 50%.
That's our claim.
That's my claim. So what variable are we using down here, right? By the way, P. So P is equal to 50% and P is greater than 50%. Okay.
Okay.
Left tail, right tail, two-tailed.
Yes.
Or,
No, one tail.
Right
two
tail.
right.
And what percent goes in there?
5.
All of it.
5%. And we have an imaginary 5%. So on the chart, we're looking at 90%. Okay. What is 90% on the chart?
1.96.
1.96.
Wait, I don't know. I didn't look.
I think 95 is
I don't have a chart.
1.96. 90% is 645. There we go. 1.645 negative 1.645. Okay, we have to. Yeah, we don't need the negative. Okay, we got to plug stuff into here. All right, so here's my formula. I'm going to put them down over here. Z equals. What is P hat? 0.43 minus P is 0.5 over the square root of P is 0.5, Q is 0.5, and N is 14. What is the Z?
Zazie.
The Z.
Ooh,
It's not going to be
5 times 0.5.
Correct.
Divided by 14. The square
In fact, he's going to be negative, so he's going to be like over here.
0.52.
Negative 0.52. This is your test statistic is negative 0.52.
I don't know how many.
And he is down over here, which means that...
I got negative 0.52.
Yeah, negative 0.52. Yeah,
That's
yeah.
what you said.
I didn't do
So-
the negative up there, I guess. Oopsie.
So, that means what?
Claim is false.
Claim is false. We circle the top, we cross off the bottom. So, do we Reject or fail to reject?
We failed to reject.
We fail to reject the null hypothesis, and the claim is
False.
false. Explain what this conclusion means in your own words.
It is equal to 5%. We are.
I don't know.
We. No.
To test the claim that the majority of all Blue Hill students are born in the first half of the year.
The majority of Blue Hill students are not, right? Born in the first half of the year?
And it actually was the second half of the year. Second half, right? Majority not born in second half. Right? We concluded that that was not a majority. Beautiful. Okay. The mean pulse rate of students in the class is,
Didn't we already do this? Or not?
oh, I guess we could have done me, but let's just leave it without me. N is 14. We need a mean and a standard deviation for pulse.
Can we already
Get rid
do
of me.
this? What page did we do pulses on?
I don't think we've ever done mean for pulse.
Can you,
69,
Okay.
65, 85,
Pretty sure.
74, 64, 57, 73, 73, 77, 77, 62, 84, 73, 71.
Pulse rate. Hey, it's
Hey,
7.6
we've got a
and
new
13.5.
animal! It's
We
an
already did.
aardvark!
Did we do it with me or without me?
The earth pig.
I don't know. N is
Was N 14?
15, yeah.
15, so we did it with me.
I got 71.7.
That doesn't, I don't really pull it up too much, right? Though 71.7, that's without me.
And I got 7.93.
7.93 for standard deviation. There you go.
Where'd my pencil go?
Significance level of 0.05. To test the claim that the mean pulse rate of all Blue Hill seniors is 70. All right, ours was 71.7. That is not 70 exactly, but is it close enough to 70 to say that that's pretty close to 70,
We're
right?
gonna find out.
That's what we're going to find out, right? So what variable do we use?
X bar.
Nope, mu.
Oh.
Mu equals 70 and mu is
Not
not equal to 70. Which one is the claim?
top one.
The top one. One-tailed, two-tailed, left tail, right tail?
Two-tail.
Two-tail. How much in each? 2.5%, which means we're looking up 95%, and we look it up on the T chart. So we need
There's
degrees of
nothing
freedom. 95% and how many degrees of freedom? 13 degrees of freedom on the T chart. 13 degrees of freedom, 95%. Like 2.160, is that true?
13.95. I got 2.160.
2.160, negative 2.160. Now what?
Can you plug it in?
Plug it in. Our equation. Woo. Okay. We need x bar minus mu over s over the square root of n. Okay. X bar is how much?
71.7.
71.7. Mu is
70.
70. Standard deviation is 7.93. The square root of 14. Plug them in. Let's see what we got.
7.93 divided by the square root of 14. I got
Boy.
0.02.
What are you doing? Eli, help me help you. What?
0.802 is what I got.
0.802.
0.802.
0.802. Okay, that's our test value. That goes right here, 0.802. Okay, where does he live?
In the middle.
Slightly to the right, but in the middle, right? So that means that,
We're good.
does that mean it's close enough to 70 to say, yep, that's pretty close to
Yeah.
70? Yep, 71.7 is close enough to 70.
We failed
Okay?
to reject.
Fail to reject, but this time the claim is
True.
true.
So,
So, explain what this means. Use a 0.05 significance level to test the claim that the mean pulse rates of all Blue Hill seniors is 70.
the mean pulse rate.
The mean pulse rate of all seniors is 70. The mean
Mean
pulse rate of all
of Blue Hills.
BH seniors is 70. Because it is close enough to 70 to say it is 70. Okay, use the information obtained in problem 49 to test at a 0.05 significance level to test the standard deviation. All right, and we want to say that the standard deviation is 10. Our standard deviation, is less than 10. Okay, our standard deviation is 7.93. That is in fact less than 10, but is that less enough or lower than 10 enough to say will always be less than 10, right? Or is that like close to 10, right? So what symbol do we use?
Sigma
Sigma is
equal to
equal to 10, and sigma is
not.
less than 10, and that is the claim on the bottom. Left tail, right tail, two tail. Left, what percent? 5 and 5. And
90.
we got 90% in the middle. And we need to look up on which chart? No, the chi chart. 90% at 13 degrees of freedom. There are two numbers. We need the chi-squared left number, and we need the chi-squared right number. The chi chart. At 90 and 13.
Or go back out something.
Left
What
is 5.892
Okay?
and right is 22.362.
Okay, now you're good.
Okay? 5.892 and 22.362. Those are our chi numbers. Okay? So, so that's how we label our chart. I'm sorry, I should have put them on here. So 5.892. Technically, we don't care about the 22.362, right? That goes on our chart, okay? All right, so we need the chi-squared. This is the formula from up above. Help me, tell me if I did this wrong. N minus 1 times s squared over sigma squared. Is that true?
Yes.
If I recopy him? Okay,
Yeah.
n minus 1 is 14 minus 1, which is 13, times s squared. What was my s?
7.93.
7.93 squared over 10 squared. That's an easy calculation. Chi-squared. Do I have to take the square root of that then?
No. Yes. No.
No, because you're comparing chi-squared to these chi-squareds, right? Okay, so you do not take the square root.
I got 8.18, but I don't know.
8.18.
I don't think I did that right. Hold on.
No, that's probably right. 8.18. Yeah. Okay. Cool. This is your critical or your test statistic.
Negative point.
Ooh, no.
5.
Nope. 8.18. Did you put the top in parentheses?
Did you square both of them?
I subtracted, not multiplied.
There you go. That's the problem. Okay. Where does he live?
In the middle.
In the middle. Oh, okay. So that means that
We have to. The claim is true.
No.
The claim is false.
the claim is false. That means that 7.93 is close enough to 10 to say that 10 is about my standard deviation, right? I don't think 7.93 is very close to 10.
But the standard deviation of 7, though.
Yeah. Well, yeah. I don't know. So, we are failed to reject again, and the claim is false. Explain what this conclusion means. To test the claim that the standard deviation for pulse rates of Blue Hill students is less than 10.
The standard deviation of
The standard deviation
BH.
for pulse rates of BH students is,
BH seniors.
No, it is students.
okay, we'll see, it should be seniors actually, is less than 10.
It's
Oh.
equal to 10, right?
Oh, is equal to 10. I'm going to say is not less than 10. There you go. Is not less than 10, right? Because our
Because
claim
we
is
don't know
false.
if it's
Because our
greater
claim
or
is
not.
false.
Yeah, we do.
Last page is stats.
Last page.
We might have to have a fry session.
Woo! Okay, 2, and we only are doing proportion and mean, right? We're not doing standard deviation. Ugh, but we got lots of stuff to do because we have to calculate like a p-bar, and we have to do all the things, right? Do we know what these variables are? Which ones are samples?
Hats.
The hats. Sample. Which ones are the population?
The line.
Not the bars.
Oh, what?
Not the bars. Just the P and Q, which we don't even need. Okay, whatever. All right, the proportion of the 14 students that have heights above 6 foot. Ooh, whose has a height above 6 foot? Juan, and that is Bill.
So 1 out of 15.
1 out of 14. And that is
0.071.
0.071. Let's just go 0.07. Okay. And we're comparing wingspan. How many people have wingspans above 7 or 6 foot?
Probably just one or two.
Hang on.
No, I think there's a couple of them. Wingspan is different. There's like 4 of them. Yeah, because I think Eli's is like Billy is the tallest, but he has like the 4th biggest wingspan.
Tate,
There's like 4 of them.
Eli, 4.
Is there 4?
Hang on. It's in
Over
inches
60.
though, isn't it?
So over 60.
So what's 6
or over
foot in
70.
inches?
No, Bill's the second biggest.
72 inches.
Oh, wait, maybe not. That's
Bill's got a 71 and a half for wingspan.
Right? Isn't
okay, so
There's
only
nobody over 70.
Eli's
There's
got
nine.
the biggest.
there's none over 72.
Woo!
Isn't that's 60?
72?
What do you mean?
Interesting. Interesting. What?
Eli's got a 71.75 and Billy's got a 71.5.
Yeah, none then.
None?
Over 6 foot.
None over 6 foot?
Yeah.
And there's one with a height over 6 foot though, right?
Yeah.
0 over 14, which is 0%. Okay, do you think 0% and 7% are close enough to being the same that we call them the same?
No.
Yeah.
I don't know. We'll see. Okay, so use a fish value of 0.05 to test the claim that the proportion of students with heights and wingspans above 6 foot is the same. All right, what do we do? What do we do for like these guys? P1 and P2 are equal. P1 and P2 are equal, and P1 and P2 are not equal. So left tail, right tail, two tail, two tail. The first one is the claim. Yep, that they are equal. Yep. How much percent goes in each one? 2.5 and 2.5. So we're looking at 95%. And if we look it up on the chart, that is 1.96. And now we got to do the big old fat formula. I'm going to do the big old fat formula up here in the thing since we only have one problem. Can we do that?
Hold on.
I'm just going to type stuff in.
Wait, where are you doing it at?
Okay, we got to do P. I'm going to do P hat first, or P bar first, right? What is X1 and X2?
We don't care.
Yeah, we do.
There's 0.
What?
A mean each thing.
Oh, it's 0 and 1.
Yeah, this is 0. This is 1 out of 14 and 0 out of 14, right? We add this together. Okay, which is 1 out of 28. So P bar is how much? 0.0357, so 0.036. Can we do that? Q bar is 0.964. Yeah? Okay.
So what do I do with that? Subtract it? Oh, no.
No, we're going to use those to put up here. Okay, what's P hat 1? 0.07. Q hat 1 was 0. Right? Because 0 out of 14. Okay, what was N1? 14 and 2 is 14. Okay. We're going to plop all those numbers in there. So I've got 0.07 minus 0 over 0.036 times 0.964. 0.036 times 0.964, all over 14. This formula makes it look as though the bar only goes over the first one, but the bar should go over the second one as well. Square root of the whole thing. Got it?
I did get an
What's
answer.
that? Yeah.
Can you go out a little bit?
Did I send that to you? I don't think I sent it to you yet.
What's
I
that
will.
first value?
It's recorded. I just need to have it
0.05.
upload. We did the first page and then like up to like here. We did up through 29, so we just got to do this today.
You don't
Okay.
need to.
But we don't have
You only
class
need one,
today.
right?
We don't at all.
From the assembly.
That would
I
like
think
square.
multiply by 2.
Wait, what's? Yeah.
Multiply by
They're
Don't
cutting
we?
out
Wait.
8th period, I thought.
They're cutting out 8th period? No. Really?
For the assembly.
Are you sure?
I thought it was right after lunch.
It is right after lunch.
1 to 2 o'clock.
I could be wrong.
Can you go out a little bit?
Yep.
What's our fish value?
0.05.
So can we just multiply that bottom number?
What'd you
by
get
two?
when you did that?
I forgot about that.
Yeah. Yeah, technically.
Bill, you want to skip his one?
Yeah, you could take this guy and multiply him by 2.
1.01.
What?
1.01.
Is the whole thing? Test statistic?
Wait.
I got 0.36.
I got 0.99.
Holy moly. I need a calculator. La, 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 la. I'm just going to look at what Jose has. Jose has something good going. 0.036, 0.964 over, oh, you missed a number. It's always that last number.
Oh,
14 on the bottom. 0.994.
That's what I got.
Hey!
You were wrong.
I don't know.
Oh, I did .071.
I'm missing how many points is it?
Oh
Write
shoot.
that down? Okay, wait.
Oh shoot. Oh, would you? So would you get 1.01? Okay, those are close. Yeah, because you use the full decimal, so that's fine. Yeah, those are close. 0.994 or 1.01, which means that where are we?
In the middle.
We are in the middle, slightly to the right, right? Okay, which means that.
It's good.
I'm missing a ladder.
Do we have the same number of people with wingspan and height over 6 foot? Yes. We failed to reject. I don't think we've rejected any of them yet. Claim is
He's not gonna
true. Explain what this means in your own words. To test the claim that the proportion of students with heights and wingspans above 6 foot are the same. The proportion of students.
Blue Hill students.
Yeah, you can put blue students. With
Seniors.
heights and wingspan above 6 foot are the same. Wait a minute, we go to lunch after this. We have 20 minutes. Why am I going so fast?
No, just
Fine.
keep going. We
You're
love
fine.
it.
Okay,
No.
okay, all right.
We need
Okay.
some.
We need
Are we going okay speed?
Yeah.
Like I feel like
this.
we're just like busting fast. Like
Don't move. What?
I think it's good because then the people can get
My
hot.
word choice, please.
I don't know, I said something. We're like busting through really fast. Okay, whatever. I don't care. Whatever. Evidently I said something that was funny.
Never mind, I was gonna ask something.
Okay. All right, ready? Last one? Your last stats
Not
problem.
ready.
Tear. So
You
sad.
never get to teach us again.
I know. Oh gosh, it's so
sad.
exciting. I mean, it's so sad.
Eli never has to turn in a stats paper again.
Actually, that's not true.
Okay, but he's not done with John Baylor yet.
Help with the last page.
Okay.
Okay, okay. Okay, we gotta go through. Oh, looky there. You and Tate can buddy up and finish it.
Because he was here.
You what?
I filled out the
You fill out more than that?
No, you just didn't do it.
You
It was
just didn't
Friday.
do it.
It was the
Because
Friday
me
of
and
district
Dale
music
sat over here
contest.
and did it. So
We did it on Thursday, but Mal and I were gone, and
Yeah,
Brian
and guess
was
what?
gone, and
I have
Betsy was
Josie and
gone.
Mallory's paper, and I don't have
What about
yours,
Brian and
and you
Matthew?
were here.
Well, that makes sense because my paper.
I'm pretty sure I have Brian and Matthews too. All right, we ready for 52? We gotta do a little bit more work because guess what? We need the height, average, and standard deviation, and we need the wingspan height and standard deviation, or average and standard deviation.
Sorry.
Okay, are we doing with me or without me?
With I don't know. Just starting to agree with numbers.
Let's go without me.
Okay.
Okay, does somebody want to do wingspan and somebody want to do height?
I just started giving me numbers. Sure. I'll do the.
I can read to you.
I'll do the
height.
wingspan.
You're gonna do
You can read
wingspan?
Ellie height.
Okay, I'll read Ellie height.
To me.
68.5,
Okay.
64.75,
Okay.
68.5,
Okay.
70.5,
Okay.
63.5,
Okay.
68.5,
Yep.
62.5, 64.5, 67, 70.25, 68.75, 61.75, 66.25, and 72.5. There's something wrong with you.
Who?
All of you.
Goodness, what I do?
I don't know.
Oh,
Silly
okay.
boys.
What do you want?
Okay. Josie's getting wingspan. All right. I'm making people dizzy here. Bleh. We're going to vomit. Bleh.
Hey, stop that.
I need X bar and S.
Okay, X bar is.
And you're doing height?
66.0.
Eli, that's so
Well,
inappropriate.
it's 66.98. So
66
six,
point.
And then
So 67.
Let's go 67.0.
I
Okay.
wasn't gonna say it.
Next. Standard deviation. Okay. All right, what you got?
Wait
Jose.
a minute.
Wait a minute.
Did you do
Aw, boo. I did Comey's and Mary's. Dang it.
Go
It's
delete.
okay.
Go
I
delete.
deleted. I just have to delete.
My NS 14, so I did that right.
What are you doing? Do not do that.
He's
Fishing.
Don't.
I saw Carter do it earlier. It's fine.
Well, it was civilian, it was pointy.
I don't care. And that doesn't count.
Okay, I've got an X bar of 66.7.
What?
66.7. All right. Okay. And
You want my S or my sigma?
S.
I got an S of 4.43.
I have a question.
Yes, ma'am.
How do they calculate the sigma and the standard deviation if you only have one set of data and that's what they're going off?
Excuse me.
Okay, say that again.
So the calculator spits out sigma and S. Why do they have both?
There's a slightly different formula for standard deviation of a population. It takes into consideration like n minus 1 or something like that. So it's just like does something funky weird to it. I don't know. It's weird.
Yeah, but all the information that they had is.
I know. Okay, fish value is 0.05. We are testing to see if the averages are the same. Look at my two averages. I'm comparing 67.0 and 66.7. Do you think that those are about the same? Yeah, I think we're going to end up circling the top. Okay, so, but we say that mu1 is equal to mu2, yeah? And mu1 is
Not equal.
not equal. Which one is the claim?
First one.
The claim goes with the top. Left tail, right tail, two tail?
2.
2. What percent in each?
2.5.
2.5.
Okay, now you're going a little too fast.
95% in the middle. And we look up on the which chart?
Try.
Nope. The T chart.
So,
You're a thief.
T chart. Because we're doing mean. And we're doing 95% at how many degrees of freedom? Shh.
13.
13 degrees of freedom. This is your last problem. Enjoy it.
No, it's not.
Yes, it is. Oh, but it's not. Because you're not done. This is the last problem that I will help you with. So enjoy it. Okay.
2.16.
2.16. Is that true? And
2.16.
negative 2.16. Yeah.
I'm pretty sure we just did that. Like,
Yeah, I think we just did that.
We did.
Yep. Okay. All right. Ready for the formula? La. I'm going to scroll to the top. Can I scroll to the top? Here we go. X bar 1 is 66.7. Minus X bar 2 is 60. No, that's wrong.
67.
The first one's 67.0. Yeah, I'm sorry. 67.0 and 66.7. I put those in the wrong order. S1 is 3.22. S2 is, and squared,
4.43.
4.43 squared, and 14 and 14.
14 and 14.
And don't forget to square out the whole bottom and put parentheses around the top, and you get what?
I'm a working on it, homie.
Like to like the.
You want a fraction? And then this, and then this, and then this. 3.2.
Okay, are we good?
Wait.
All right, here's the formula.
Plus another
If you can read over top of my mess here.
4.43 over 13. And there.
Josie got an answer. What'd you get,
I
Josie?
got the 0.406.
0.46?
I got
Oh.
0.204.
No. 0.406.
I got 0.0874.
Maybe you're right.
I got 21.4.
I didn't square
so-
them. I'm wrong.
Okay, Josie's wrong. She knows she's wrong. 0.0874?
I
Is
got
that still in the running?
That makes sense.
2.05.
What?
My answer makes the most sense.
Your answer makes the most sense? I think so. Can I look at your calculator? How you typed it in? Ooh. Oh man, that hurts my butt. Okay. 0.3. Yes, that is true. 3.22 squared over 14 plus 4.43 squared over 14. What's the matter with
I
that?
got 0.204.
Yeah.
That's what I got.
0.204.
I don't know.
0.
Why not just add them and then divide them both?
0.205.
Yeah, 0.205.
Say that again.
0.205.
Add them and then divide by 14. Yes, you should be able to, but make sure the whole thing is underneath of the square root.
It is.
It is?
Yeah.
205.
I don't know. Did you square them both? I don't know. 0.205. And he lives where? In the middle. Which means that wingspan and height average is the same. We didn't reject anything, right? Failed to reject it all. Claim is true. Use a significance level to test the claim that the mean height and wingspan is the same.
The proportion
The
Blue Hill Senior.
no, it's not proportion. The mean height and wingspan for BH seniors is the same. Yeah? 66.7 and 67 are close enough to be the same that they are the same.
The mean of Blue Hill Senior's height and wingspan is the same.
Yep.
Okay.
Yep.
Question.
Look at that!
Can we keep our charts?
You can if you want. That's fine.
Why do I ever do that again?
In case
I don't know. In
need
case you have to
for
have it in
our
college. I don't know.
Here you go.
I would take make sure your name is on your big old fat packet. I would check them. And I have like until, I think I have like till Wednesday to get them in the grade book. I'm going to do it this weekend though.
You shall check them.
What?
You will check them.
What you're saying
You're
is,
gonna do it this weekend,
we
so
could
that you can
technically
figure out
wait
the
till Wednesday to check this.
Yeah.
So you can grade all of Eli's
All right, bye,
papers on
Aubrey.
Monday.
No.